Good day everyone, I'm Michael Hanzay Sagana and I'm going to present my handheld catapult. Let's discuss the physics concepts of my handheld catapult. Pulling the arm and the trigger. When pulling the arm, the hand exerts force in this direction, but at the same time, the rubber bands exert force in the opposite direction. The same with the trigger, this shows Newton's third law of motion. For every action, there is an equal and opposite reaction. Releasing the arm and the trigger. After pulling the arm, it should be placed under the trigger to secure it. The arm doesn't move anymore as the force it exerts from the rubber bands is equal to the force of the trigger from the rubber bands. There is no net force. When the trigger and arm are secured, the rubber bands are stretched. In this case, the rubber bands store elastic potential energy. Adding projectiles to the bucket. After placing the projectiles stay at rest because the normal force acting on the bucket is equal to the gravitational force of the Earth. When the projectiles are still, they possess gravitational potential energy. It will stay at rest until it's acted upon by an imbalanced force. Pulling the trigger. When pulling the trigger, the finger exerts force in this direction, while the rubber bands are in the opposite direction. After pulling the trigger, the elastic potential energy of the rubber bands turned into kinetic energy. It causes the arm to move and throw the projectiles. When the elastic potential energy is turned into kinetic energy, mechanical energy is present. It is the sum of potential and kinetic energy. The mechanical energy is not only present in the arm, but also in the projectiles. When the projectiles are thrown, the motion they project is controlled by the motion of gravity. It shows projectile motion. When the mass of projectiles increases, the acceleration of the arm decreases. It shows Newton's second law of motion, which states that the acceleration of an object depends upon two variables: the net force acting on the object and the mass of the object. When the arm swings, it stops at a certain position and bounces until it remains at rest. It shows an inelastic collision that states that momentum is conserved, but the kinetic energy is not conserved. It can also be observed through projectiles when they hit the ground and bounce off until they remain at rest.